Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over part 2 of the multi-part series on how to multiply and divide rational expressions. We're going to be focusing on rational expressions with binomials and trinomials in this example. If you would like to take a look at how the process applies to monomial rational expressions, go ahead and take a look at part 1. Alright, before we get started, let's take a look at some formulas that will be guiding our problem solving process. These formulas were introduced in part 1, and we are going to be applying them in part 2 also, okay? So, formula number 1 has to do with the product property of arithmetic. So let's say you have a fraction a over b, and you're multiplying it by another fraction c over d, where b and d are not 0. What you have is a situation where you simply multiply the numerators across and the denominators. Okay? Remember, you do not need to find the LCD when multiplying and dividing rational expressions, which also applies to fractions. Secondly, what if you have a situation where you are dividing two fractions or rational expressions, also known as algebraic fractions? In a scenario like this, you simply drop, change, flip. You drop the first one, the dividend fraction or algebraic fraction, a over b, and then you change your operation to a times, and then you flip the divisor, okay? So that becomes d over c, okay? Some people call it keep, change, flip, drop, change, flip, whatever it is. You just have to remember that whenever you're dividing a number by a fraction or two fractions, you multiply the dividend by the reciprocal of your divisor fraction, okay? And then when you have it in this form, you can simply apply the property introduced in part 1, multiply the numerators across, and then the denominators across. Okay? Alright, another property that we went over in part 1 had to do with dividing. If you divide two identical factors, for example, a over a, scenario like this, you just divide the numerator by a and the denominator by a. You have 1 over 1. And your final answer is going to be 1. So 1 over 1, and your final answer is 1. Alright, part 4. This formula, we didn't introduce it in the previous example because it's not applicable. Let's say you have a minus b, okay? What you want to remember is that whenever you're subtracting two terms, order matters, okay? A minus b is equal to the opposite of b minus a. When you're adding a plus b, for example, addition commutes just like multiplication, okay? A plus b is equal to b plus a. The order doesn't matter when you're adding, but whenever you're subtracting, the order does matter. So if you reverse the order of a difference, you have to introduce a negative sign to compensate for that switch. But for adding, since the addition property is commutative, then you don't need to introduce this minus component. Alright, let's consider this example. This is going to be a multiplication example. So let's say we are to multiply the following expression. We have x squared plus 2x minus 48 divided by 60 minus 10x. And then this rational, let's say we are multiplying it by x squared plus 4x minus 12. And this entire numerator is divided by another polynomial, a quadratic trinomial, x squared plus 14x plus 48. Okay, so the steps that we're going to use are as follows. So we have the list of steps to your right. First of all, we're going to combine, and then we're going to decompose monomials. We don't have any monomials here, so we'll skip that. And then we'll factor non-prime binomials and trinomials. So we have a binomial here and 3 trinomials, so we're going to have to factor that. And then we are going to divide out common factors and multiply horizontally across. Okay? All right, let's start out by combining. To combine, we are simply going to have x squared plus 2x minus 48 multiplied by x squared plus 4x minus 12. And then we'll divide that by the denominator, which is 60 minus 10x times x squared plus 14x plus 48. Like that. Okay, so we have a numerator. We have two factors in the numerator, left and right, and then left and right in the denominator. We're going to advance to step number 2, which is the factorization of the non-prime binomials and trinomials. Okay, so let's start with the numerator, the left numerator. Okay, so left numerator. The left numerator is what is it? It's x squared plus 2x minus 48. We're going to factor this by using the x game or the AC method. There are other methods that can be used to do it, but we're going to be using the AC method here. A is 1, the leading coefficient. C is negative 48, so we have negative 48 as A, C, and B as 2. So we're going to ask ourselves what two numbers multiply to give you negative 48 and add to give you 2. So you take a look at all the numbers that multiply to give you 48, and 6 and 8 works perfectly, but the sum is positive, so the smaller number has to be negative, or the difference is positive. Okay, so now in this scenario, A is equal to 1. Now, since A is equal to 1, there's no need to group, no need for grouping. You can group, but it just takes more time, okay? So no need for grouping here. You can just jump from this expanded form directly to the factored state by extracting these two numbers we got from the x game, okay? All right, so we have factored the left numerator. So let's insert it back into the problem, x minus 6 times x plus 8. Now we're going to go ahead and shift gears and take a look at the right numerator. Okay, we're attacking the numerators first, and after we'll take a look at the denominators. Okay, all right, so the right numerator is another quadratic trinomial that we are going to factor using the same procedure that we did in for the left numerator. Okay, we're going to be using the AC method again. Let's go ahead and create our nice little x. AC goes on top, B goes on the bottom. All right, AC is negative 12 and B is 4. Now what works here? Two numbers that multiply to give you negative 12 and add to give you 4. So 6 times 2, 6 and negative 2 should work nicely here. So since A is equal to 1, no need for grouping again. So we just have the factored state x plus 6 times x minus 2. Okay, so numerator on the right, the factored state is x plus 6 times x minus 2. Alright, so that's that. Now we're going to take a look at the denominators. Let's start with the left denominator. The left denominator, we have the polynomial. Let's see what it is. 60 minus 10x. Okay, 60 minus 10x. Now this right here is not a trinomial, so we have to use a different approach. Okay, so all we just have to do is factor out the greatest common factor, and that should be it. So what's the biggest number that goes into 60 and 10? The GCF is 10. So you factor out 10 and you're left with 6 minus x. Remember, when you're factoring out, it is as though you're dividing. Okay, so when we factor out 10, we're dividing 60 by 10 and 10 by 10. So that's how you have this as your factored form. Okay, so we have that divided by 10 times 6 minus x. And then lastly, we have the right denominator. Okay, so we have the right denominator. For the right denominator, we have x squared plus 14x plus 48. So we're going to factor that also. X squared plus 14x plus 48. We're going to employ the same methodology that we used for the numerators, the AC method or the X game. AC is 48 and B is 14. Now, what works here? Two numbers that multiply to give you 48 and add to give you 14. 6 and 8 works perfectly here. A is 1 in this problem, 2, so we can skip grouping and jump straight to the factored form. Okay, so now let's go ahead and insert the right denominator back into the problem. So it's x plus 6 times x plus 8. Let me check again just to make sure it's correct. Okay, yes. X plus 6 and x plus 8. Now we are done executing step 2. So now we will advance to step 3, which involves dividing out common factors between the numerator and denominator. Okay, so x plus 8, notice it's a package. They go together. So they come together and they go together. You can pick out terms from a sum or difference to divide out. That's inaccurate. Okay, so this as a package goes there once, and x plus 8 as a package goes out once. Those linear binomials. And these linear binomials, two are identical, so you divide them out just like that. And then we can multiply them out. So we have x minus 6 times x minus 2 divided by 10 times 6 minus x. Okay, now let's take a look at the denominator for a second. 10 times 6 minus x. What you notice is that 6 minus x is similar to this, it's just reversed. Okay, so can we reverse the order of a difference? We can't just simply reverse the order. Whenever you reverse the order of a difference, you have to introduce what? You have to introduce a negative sign. Okay, so if we rewrite this problem as x minus 6 over x minus 2 divided by 10 times, and then reverse the order of 6 minus x and write it as x minus 6, you have to introduce a number in the front. Okay, like that. That's to compensate for the switch in the order of the difference. Okay. Alright, why did we reverse the order? Well, we wanted to match with this factor, this linear binomial in the numerator. So this goes into itself once, and it goes into the numerator once. Now, when it comes to switching the order of a difference, it doesn't matter if it's the numerator or the denominator, because this negative can be moved around. Okay, I'm going to move it up in a second. So we have x minus 2 divided by negative 10. Now that negative can be moved to the top. I can write this as negative x minus 2 over 10. And then distribute this negative across x and negative 2, which yields negative x plus 2 divided by 10. And ladies and gentlemen, that's your final answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of operations and rational expressions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any algebra questions in general, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips and worksheets can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.